Hello everyone, welcome back to another Unity 2D tutorial. Before we get started, I wanted to take a look at the syllabus and remind everyone sort of what's going on. So Game Jam 1 is officially over, and I will reveal the results soon, but as far as your homework goes, we are currently still working in Unity 2D for this week, and then another week after that, and then we'll get into more 3D stuff and some more complicated topics. Okay, and so yeah, we'll talk about the final project here in a few weeks. So back in Unity, I have pretty much a copy of the game where we left off last week with our little character. I'll run it so we can see where we're at. So I can jump up, and I can move around, but I can't, I can just jump in the air like this, and I can't actually move left and right and jump at the same time. There are lots of problems with this movement controls. So the reason we did it like this last time is to keep everything simple. It's sort of like what we've been doing in 3D, so it's really easy to understand. But this week we're going to go with a little bit more complicated approach. Not too terribly complicated, but it'll provide us with a lot more control over how our character moves. Okay? So let's get started. So what are we going to do? Well, to start with, I'm going to make a few changes to our character over here. So over in, and I'm doing this first just so we don't forget, over in the rigid body, you can adjust the gravity scale, but I'm going to leave it at 1 for now. And I'm going to change these 3 boxes here. These aren't too terribly important, but it's just good coding practices for movement controllers to leave collision detection on continuous, in a sleeping mode, never sleep, and interpolate to interpolate. Okay, and our Z rotation is frozen. There's one other thing I wanted to do, which was to add a physics material to our character. I'm going to go to Create, 2D, and be sure not to add physics material because that's for 3D. Go to 2D and then physics material 2D, and I'll just call this for now character not. Okay, and I'll set my friction and bounciness to 0, and I'll just drag and drop this onto the player. And now that should be good there. One other thing I'm going to do is right-click our player and add an empty game object, and I'm going to call it ground check. This is going to be the object responsible for detecting if we're on the ground, because I only want to be able to jump when we're touching the ground. And specifically, I want this object placed at the foot of our character, so I'm going to hold Control and sort of snap it down to the feet. That should be pretty good. Okay, now the majority of our changes are going to happen in code, so I'm going to save this, and I'm going to go back into the code. But before we do that, I just want to mention the things we're going to do. So we're going to make it so that way our player can only jump when we're touching the ground. We're going to actually improve the jumping and moving, and to make it so that way our character doesn't slide around. I'm going to make it so that way if you hold down space, he jumps higher than if you do like a little quick tap. I'm going to make it so you can press W or space. We're actually going to rework the input system altogether, and then also at the very end we're going to actually give him a little walking animation. And we'll also flip the model too when he's going left versus when he's going right. Okay, so with that out of the way, let's get started. And we're actually just going to rip some of this out. Okay, and we'll get back to some of that later. So up here we need to add a few more things. I'll leave those where they're at. I'll add a private float called horizontal, and we'll get to what that means in a second. I'm going to actually change these to floats as well to be a little bit more precise. I want another bool for is facing right, and this is just exactly what it sounds like. It's true if our character is facing right, and this is used to determine whether or not we want to flip the model or not. Or sorry, the sprite. Okay, and this can be true by default since our character is facing right. Okay, and now a few other things. I'm going to do something I don't think we've done in the class yet, and that's called a serialize field. If I hover over it, you can see forces Unity to serialize a private field. And so basically, for our purposes, what that means is our player here is going to have a field like this, so where you can change the object in the inspector, but it'll still be private. Okay, and not all that necessary. These are private variables, but it's useful to know for your future games. I want a rigid body 2D, I'll call it RB. I want another one of these. Oops, serialized private. Transform, I'll call, this is the ground check, empty object that we just created. And I want another serialized field for something called a layer mask. And we don't want to check if we're, to jump, we don't want to check if we're just touching any object. We want to make sure we're specifically touching something that has that's in the layer called ground, and we'll get to that in a second. Okay. In fact, we could probably do that now, too. I'll do that now so I don't forget. And spend 10 minutes wondering why it doesn't work. Okay, wait for it to reload. On our grid terrain, I'll make sure I have the terrain object selected. Go to layer, and I'll add a new layer, probably here. And I'll just call it ground. And okay, and now I need to make sure I add it with terrain. And if you didn't have a tile map set up, you would have to, and if you just had your objects just in the hierarchy like this, you make sure you select all of them and apply the ground layer to that. Okay, now let's actually get into some of the code here. And what does that look like? Well, let's see. In update, let's define horizontal to be our input dot get axis raw returns the value of the virtual axis identified by axis name with no smoothing filtering. Okay, so what does that mean? Let me check that out. Okay, so I'm going to save this and I'll go back into Unity to show you what this is. So in edit, in project settings, yes, project settings, input manager, you can see that there are all these axes, and these axes have their, if you click the little drop down menu, horizontal, you can see they have negative and positive buttons already assigned. So like left, right, alternate buttons are A and D for moving left and right, respectively. For vertical, we have up and down, WS, but we don't want to just move vertical, we want to jump. So for jump, we have the positive button, but we also want an alternate positive button, and we want that to be W, because we want to jump upwards. Okay, and that's all the changes I believe we need to make to the input manager. And now, what do we want to do? We want to also say RB for rigid body, velocity equals, we're changing the velocity of our character here, new vector 2, we want that to be horizontal, oops, horizontal times jump speed I think this should be, I think I got it wrong in my reference. I think this should be move speed, because we're going horizontal here, we're not going up. Oops. Horizontal times move speed, sorry. Okay, and I want rb.velocity.y for our y direction. Okay, that should be good there. And now our first conditional, and this is going to be for when we're actually pressing a button associated with that input manager I just showed you. So if input, and now instead of doing get key down, we're going to just do get button. And the reason we want to do this is it sort of abstracts the input commands, because get button can mean a different thing if we changed the value in the input manager. So just by putting jump here, any key that we had assigned, like I had, space was already assigned and I assigned W as the alternate jump key. I could have assigned anything else and that would also work here. So now we want to do if I'm jumping and we are grounded. This is a function we haven't made yet, but I'll just put it in there. Then blah blah blah, let's do then jump. Okay, but now let's actually make this function. Okay, so this function is very simple to make. It will be a private. It's going to return a bool, as you can imagine, because is grounded. We want this to end up being true for us to be able to jump. Make sure I type it right. Is grounded. Okay, now what happens? We want to return a bool, remember? And this, how are we going to know when we're colliding with the ground object? Well, we're going to use something called physics 2D. We're going to use a function called overlap circle. And what this does is it creates a circle at a position with a certain radius, and then it detects if something with this layer is colliding with that circle. So let's go ahead and fill in the parameters. We want our ground check dot position. So this is sort of the center of the circle we're creating. This is the radius, and then the int layer mask you can see there is what it's checking that we're colliding with, and that is going to be ground layer. And I need to remember to actually input that at the end. I need to actually put that in the serialized field. Okay, and that's actually it for the function. And you can see it no longer gives us a little error. Okay. And now what do we want to do if we are, if these things are happening? We want to jump. That's simple enough. It's similar to moving forward. We want to change our RB velocity. Set that equal to a new vector 3, oh sorry, vector 2. RB dot velocity. We don't want to change our x value, so we'll just leave it there. And I want jump speed. Okay. And now the next part is actually what's going to control us adjusting our jump height based on how long we hold the space key. So what I can do is, it's actually a lot simpler than you might think. If input dot get, instead of get button down, we want get button up. I had to actually sit here and think about this for a while because it's kind of counterintuitive at first. But if we released the jump key and we are still going up, then we want to basically half our momentum. So, and rb.velocity.y is greater than 0, f, because it's a float. Then we want to set, basically I think it's just this, except now it's whatever our current velocity in the y direction is multiplied by half. Okay, so if you think about this sequentially, right, if we're just standing, we press the space key, we go up, right? Now if we release that jump key and we're still going upwards, that means it was a short press, right? It means we didn't hold the space key until we were at our full height. And in that scenario, we want to stop moving up, and so we half our velocity. Okay? And yeah, that should be good. And now we're going to actually input, and let's give that a try actually. Let's see if that works. Before we move on, let's test these things. Okay? Before I forget, over in player movement we have our serialized fields. We need to make sure we drag in our rigid body component and our ground check object here, and then our ground layer, we want to make sure we have the correct layer selected. Now let's give that a try. Okay, we can move left and right. I did a long press, short press, super short press. Cool. Let's see if I can make it across. I can. Can I make it up here? I can. Cool. And I can even move left and right. I can't jump in the air, which is perfect. Awesome. Cool. Now let's actually make the player flip left and right whenever we're pressing the left and right button. Okay, so this one's a little bit more complicated than is grounded, but it's still not that complicated. It's private void flip. Okay, now we need to basically check, we need to use what we wrote up here, the is facing right. If is facing right and our horizontal is less than 0f. Oh, yeah, I guess I kind of forgot to explain what that was earlier, didn't I? Horizontal is just a number between -1 and 1 that determines the direction in which we're moving. Okay, so -1 means we're moving left, and 1 means we're moving right. Or basically, a positive number means we're moving right, and a negative number means we're moving left. So therefore, if we are facing right and we are moving left, then we know that we want to flip the camera. Or the opposite is true. So if we are not facing right, and remember you do that with the exclamation point, if we are not facing right, or left as it's otherwise known, and the opposite of this, which is horizontal, is greater than 0. Okay, that should be good. So in both of these cases, we know we want to flip the character, and that's pretty simple to do. We just set is facing right. Well, we need to, if we are facing right, then we want to tell the future iterations of this program that we are not facing right anymore. So if this was true, it'll make it false. If it was false, it'll make it true. And then we actually need to do the flipping. So we'll say vector 3 local scale. This will make more sense once it's written down. Transform.local scale. Okay, local scale dot x times equals, and this is just multiplying, -1 f transform. I'll just write it down first and then explain it. Local scale equals local scale. Okay, so what does this do? We negate what the current is facing right value is. We set local scale to be whatever the current scale of our object is. And if you remember, if I click here, if I look at the local scale of our player object, if I make it -1, what does that do? Well, it flips our character. Okay, pretty simple to understand there. But we set this local scale value, we multiply it by -1, and then we assign our actual player's transform to that -1 value. Okay, and just like that, oh, now we need to actually do it here. So in update, what we're going to do is we're going to check this flip function every frame, and if these end up returning true, then we're going to do this stuff. If not, it won't do anything. Okay, so just like that, we should be good in that end. So, yep, cool. Already much better. Now I would like it if our character would actually use the beautiful animation frames that I created. So let's go ahead and get that started. Okay. So what do we want exactly? Well, I want it to stand still in this idle frame whenever we're not moving, and I only want him to do the little run when he is moving. So we'll add that code in a minute. But first we need to actually create the animation. So in player, I'm going to... What am I going to do? I think what I should do first is go to Window, open up Animation, and I'm going to drag this down here by the console. This is just where I like to keep it. No animatable object selected. I'll make sure player is here, and I will create an animation, and I'll just call it walk. It's more of a run, but this is fine. Okay, Now what are we doing? If I go into here, I will add property sprite render, and this is referring to the player object. So all these components belong to the player. A sprite renderer, and these are basically just objects that variables that I can change at any point in the animation. What I want is the sprite. Okay, so now I can edit the sprite. Yes, so over here I can actually do the changing. So what I'm going to do is I'm going to, how many are there? There's 1, 2, 3, 4 frames that aren't standing still. So I'm going to add 1, 2, 3, 4 frames here. I'm going to press the record button. Okay, and I'm going to make the first one this one. Okay, I'll make the second one this one. I'll make the third one this one. And I'll make the fourth one this one. And then I will restart it back at this one. Okay, so now you can see he does a little run, which is nice. Now if I can stop the record, play it, and oh, okay, we need to delete this key, so that way this is the total animation. And look at that, he does a little run. Isn't that nice? I'm not sure if I like how fast it is, so let's slow it down a little. I'm gonna drag I'll make it, instead of 5, is it a millisecond, I think? I'll make it 7, 14, 21, oops, this is 21 and 20. We need to make sure they're all the right frames too, so I don't get them backwards. 7, 14, 21, 28 is the right multiple. Okay, that should be a little slower. I like that, that looks pretty good. Okay, so with this animation complete, let's actually make it work. I don't think, is it working by default? Okay, so now he's just always running, but we don't want that to be the case. It looks really good, by the way. I'm touting my own artwork. Anyways, okay. Let's work with not the animator window, or not the animation window, but the animator window, and I have that set up to be right here. We have our walk state. Before I forget also, I need to make sure, oh, it already dragged it in, perfect, player. And if this isn't here by default, you just take the little player animator and drag and drop it in there, but it's there for me. So what we need to do is manipulate this animator window. I don't want it to go from entry straight into the walk animation. I want a new empty state, and I'll just call this idle. A lot of games you'll have an idle animation, but I didn't do that for this one. It's just going to be him standing still. And I don't want this, so I don't want it to go straight into walk. I want this to be the layer default state. Okay, you can move these around however you like. Okay, go from idle, and then from idle to walk, and from walk to idle. Normally you might utilize this any state or the exit state a lot, but in our game we only have 2 states, so this will do. And to go from idle to walk, I'm going to actually create a new parameter here. A bool called isWalking should do fine. And to go from idle to walking, we want to make sure isWalking is true, and for walking to idle, we want to make sure isWalking is false. And then we'll delete the exit time, say no to exit time. I want 0 on the transition duration, so that way it happens instantaneously. Make sure it's 0 for both of these, and that should be good there. Actually, so this shouldn't, we're not adjusting that parameter, so yeah, nothing's happening. So now we actually need to go into the code and make it happen. So in update, I'll put it right here, should be good. If rb.velocity.x, right, if we're moving in the left or right direction. If we're not moving, so if the velocity is 0, then I need to change something in the animator, so let's do that. I'll say private animator. I'll call it anim right now, and I'll define what that is here. Anim equals get component. I forgot how to do it for a second. Animator, just like that. Okay, so now it knows what we're talking about. What do we want to do? I want to reference, or I want to set a bool parameter that we just created. And the function looks like this. We define as a string the parameter, which was is walking, I believe, just like that. And then whether it's true or false. So if we're not moving, I want is walking to be false. And I guess else, so if we're moving left or right, then I want to set this to true. Okay. And I think that's good to go. Let's give it a try. Okay, not moving, perfect. And look at that. Perfect. What a lovely game we have here. Can I just walk up? No, okay. Perfect. So that's going to do it for this tutorial. If you have any questions on these materials, I actually started checking the YouTube comments for the videos that I've been posting. You can also reach out to me directly via email, as always. Yeah, particularly if you have questions about this content or about anything in the course, yeah, please don't hesitate to reach out. I'll see you in the next one.